Okay, so today we're going to talk about properties of logs, and when we talk about properties of logs, we're talking about how can we manipulate logs algebraically so that we can solve the problems easier. So on this, with this one, I want to just go over the rules with you. Okay, log v is defined only when v is greater than 0. So if this v is less than 0, it does not work. It's undefined. Okay, log of 1 always equals 0, and log of 10 always equals 1. Okay, this is one of those tricky ones, like, you know, the exponent of anything to the 0 power is 1. Similarly here, don't forget those, okay? And log 10k is k for every real number k. We talked about this a little bit last time, that those logs can cancel out, so just be aware of that. And then 10 to the log v, likewise the same inverse here, is equal to v. The same exact rules work for natural logs. So natural logs and common logs, and actually if you were to have a log of any base, would do this. All right, so we're going to continue on to some examples. So this example 1, down here, it says log of 2x equals 3. So how can I use these rules to solve my problem? And I'm going to use the base 10 thing again. So not necessarily, like I put these rules up here, but you can use rules from before. So 10 to the third power equals 2x. So then I know 10 to the third is 1,000 equals 2x. And I divide by 2, and I get x equals 500. Now, another rule that we can use using these rules up here is I can go ahead, I know I did this. Did I take too long? I probably paused for a second because I was thinking about the other way to do it. All right. So anyway, is that you can actually use these rules. Now this is, I can take both sides. I can do the same thing like when you multiply both sides by a number. I can do that with logs too. So I can take this right here and I can do 10 to the log 2x equals 10 to the third. See, 10 to the log 2x equals 10 to the third. Now watch. The 10 and the log cancel out, and I'm left with 2x equals 10 to the third. It's the exact same thing. It's just another way to do it. You can't always use this rule. This doesn't always work, but this always works. For example, on your practice problem, you're going to have to do e to both sides to get it to work, and you'll need a calculator. There's your solution. Hold on, I want to pause for a second and go back. Just a moment. A little further. Oops. Okay, moving forward. Right here, solution. Okay, I want to talk about I want to talk about this down here. Okay, you guys, when I copy and paste these from the book, they talk quite a bit about in the solutions about checking your answer by graphing. Okay, you can do that. I'm not going to require that. It's very easy. You plug this into y1 and this into y2 and find the intersection, and that will give you the same solution. If you want to check your answer that way, you may do that. All right. So properties of logs. Now you'll notice these are all big and covered up by all kinds of stuff. So, oh, I hope I moved that. No, I didn't. Okay, back up. Okay. So, I don't know how to do this. Okay, sorry, I'm still learning. Okay, so here we go. Properties of logs. We're going to talk about these extensively. So the very top one, we say for all v and w greater than 0. Okay, the log of v times w is the same thing as the log of v plus log of w. Notice the same thing works for ln. Now, we're actually going to work backwards most of the time. We'll say, oh, if we can add these together, then I can change it to a single log and multiply the insides together. These are rules you need to make sure you memorize. For this test, more than likely, I will let you have a note card where you can write these rules down, but it will be best if you know these. Now, you notice the quotient, the same thing. If I divide, I subtract, okay? And I can go backwards. So if it's log v minus log w, it's v divided by w. Again, most of the time we're going to be working backwards, not forwards. All right, now we'll see if we can get that to disappear so that I can talk about this. Okay, now this is a really important one. You notice the little k, log vk. Okay, if I want to get it out of the log, okay, I can move it in front of the log. So it's k times the log v. That's a rule that we're going to use quite a bit. All right, now we're going to move forward. Using our new little rules. Example 2, maybe? There we go. All right. So now I can take these natural logs, and I can first of all I want to combine them all. I want to make it a single log. And that's going to be most of the time what you're going to do is make it a single log. This is a natural log, but it's still a single log. So I'm going to move that 2 on the inside first before I do anything else. So it's natural log of x squared. All right, then I can combine my pluses. So natural log of 2x times x squared, which is 2x to the third. I'm going to pause for a second. Here, since I put these together inside, now I can simplify them. So it's 2x to the third. I could at this point move the 3 to the outside, but I don't want to do that. So then I'm going to divide by 3y. And now I have the natural log of 2x to the third over 3y. And that is my answer. I can no longer move that 3 to the outside because I have the minus divided by 3y. Here's your own. And there's your solution. Okay. Example 3. Okay. So now we're going to talk about being able to prove things. Now you did a lot of proof stuff in geometry, I hope, or in integrated you did some proofs. This one is one where I want you to be able to prove that something is either true or false. Most of the time it's false. Okay. Now it says use graphical or algebraic means. You can plug it into a graphing calculator. That's perfectly acceptable, but I'm going to do it using algebraic methods. So I'm going to pick a value for x. It doesn't matter what it is. We're just going to try something and see if it works or not. Okay, this is trial and error. So I pick x as 2, the natural log of 1/2, and 1 over the natural log of 2. And then I'm going to plug it in a calculator, and I end up with a negative 0.693 for the natural log of 1/2. And the 1 over natural log 2 is 1.44. They are not the same, so the statement is false. If you find any situation where, where the solution is not true, then the entire thing is false. All right, so this is one you're going to try on your own, your practice problem. Now, the solution didn't actually end up in there, so I went ahead and did the solution, and I can talk you through it. So maybe I did it. Where'd it go? It's coming. There it is. Okay. So there are many possible solutions to this. So you could have picked different numbers. No matter what, you would have been able to get the same thing as I did. So I simply let a equals 2 and b equals 3. If you chose different numbers, that's perfectly fine. So I did log of 2 plus 3 equals log of 2 plus the log of 3. So we know, and before we even get into this, we know the rule when we have log 2 plus 3 is actually 2 times 3. So we're proving that this is wrong, that it's not the same, that the rule we have is actually right and this one is wrong. So I take the log of 5, and I get 0.69. And then I take the log of 2 plus the log of 3, and I get 0.78. And they are not the same. And that is it. I will see you tomorrow.